Alright, so in class we talked about the definition of a derivative. Here it is right here. We talked about basically where it comes from, and we talked about that it represents the slope of a tangent line in class. Hopefully what you took as well from this is that while this thing looks really scary, maybe it's not quite as bad as it looks. What we didn't do in class, though, is we didn't talk about how you would actually use this definition of a derivative to find the derivative of a function. So that's what we want to do in this video. We want to start with the really simple example. Find the derivative of f of x equals 4x. Now, to find a derivative, we're going to use this definition, obviously, and we need a couple of things. We need a function, f of x, that's usually given to us, and we need to find f of x plus h. Then what we're going to do is we're going to plug those two things into this thing and see if we can simplify it. So the first question is that you're always going to be asking when finding a derivative using the definition is, what is f of x plus h? Well, we're given f of x and we want f of x plus h. Now, for a more complete description of what function notation is, and that's what we're using here, we're using function notation to do this first step, please click the link to the video that should be popping up on your screen right now. I'm just going to give you a real quick description of how we do this. We have f of x equals 4x. We want f of x plus h. And what this means is we're going to replace x in the previous line with an x plus h. So we're going to replace this x with an x plus h. The 4 used to be multiplying x, and now the 4 is multiplying x plus h. So that's how you do that. Now that we have f of x and f of x plus h, what we want to do is plug all that into this formula. So we're going to copy everything down, except we're going to replace f of x plus h with 4 times x plus h. And we're going to replace f of x with 4x. The minus stays. After you've plugged these things in, hopefully what's going to happen is you're going to have something that you can simplify. Now, if you're an algebra student, the first thing you probably think when you look at this formula here is, well, maybe I can distribute that 4 through the parentheses. Maybe I can multiply the 4 by the x and also by the h. And that would be a perfect idea. We're going to copy everything else down. We're going to copy down the limit as h goes to 0. And we're going to distribute the 4 through the parentheses. That's going to give us 4 times x plus 4 times h. Everything else gets copied down, and it looks something like that. Now look at what we're left with. We have 4x plus 4h minus 4x. Well, we have a positive 4x here and a negative 4x there, so those two can actually cancel. Now let's see what we're left with. Always copy your limit down. We're left with a 4h in the numerator and just an h in the denominator. Well, look at that. We have an h in the numerator and an h in the denominator. You can actually cancel those two things out. That just gives us the limit as h goes to 0 of 4. Now at this point, what you'd usually want to do is you'd want to take the limit as h goes to 0 of whatever function is in here. And that usually involves, at least the first step would involve, taking h equals 0 and plugging in h equals 0 wherever you see an h here in this equation. So where in this formula do you actually see h? Well, you don't see it anywhere. It doesn't appear. So this last step is kind of anticlimactic. The limit as h goes to 0 of 4 is just 4. Since an h didn't even appear in the formula, there's really nothing that you have to do. So I promise the next example will be much more satisfying because we'll actually have to do something to take this limit. But let's go back and look at what we just did for this problem. We wanted to find the derivative of 4x, and we went through all the steps. We plugged everything into our definition of the derivative. We used algebra mostly just to simplify, and we got an answer of 4. Now if you wanted to use the fancy calculus notation to give an answer, that notation would be f prime of x equals 4. That prime represents a derivative, so this just means the derivative of the function f of x is 4. So the next example is slightly more complicated. What we want to do is we want to find the derivative now of f of x equals x squared. So the first step is always going to be to copy down the definition. And you look at that definition, you say, okay, every single time we need f of x plus h. So, okay, so function notation tells us that we're just going to replace x in our function with x plus h. Now previously this x is squared, so now the x plus h is going to be squared. We've just replaced x with x plus h. So now that we have our f of x plus h and our f of x, we can just plug those in like we did last time right over here. Going to copy everything down, except this time we're going to replace f of x plus h with x plus h squared. And we're going to replace f of x with x squared. Now, like last time, the goal is simplifying this in a way that will give us a simple answer. So how do we simplify x plus h squared? Well, unfortunately, we can't just square the x and square the h. It's very common, but that is illegal. What we have to do is we actually have to write out the x plus h twice, because x plus h squared is x plus h times x plus h. And the way to multiply this out legally is to do what we usually call FOIL. What that stands for: first, outer, inner, and last. That means we multiply the first two terms together, we multiply the outer two terms together, multiply the inner two terms together, and multiply the last two terms together. Basically, it's just called distribution. So if we FOIL out our x plus h squared, that's going to give us x times x, which is x squared. That's going to give us x times h, which is xh. It's going to give us h times x, and it's going to give us h times h, which is h squared. Now, those four terms that I just copied down is just this thing in parentheses squared. We still have to copy the rest of it down. So don't forget you still have a minus x squared, and you still have a divided by h. And as usual, we have a limit as h goes to 0. So can we simplify this? Well, yes, just like last time, we have a positive term and a negative term that are the same. So we can cancel those two out. The other thing that we can do in this step, without doing too many steps at once, is we can combine the x times h and the h times x term. They're actually the same term. So we can do what we call combining like terms, which you've learned in previous algebra classes. We combine these like terms, and that leaves us with 2xh. That's those two terms combined. We have a plus h squared left, and don't forget we still have an h in the denominator, and we still have that limit as h goes to 0 outside. Okay, now is where your skills from your previous algebra classes come in handy. Sorry there's no way to avoid this, but what we have to do now is we have to factor an h out of each term in the numerator. The way that we factor is we take an h outside the parentheses in the numerator. We're going to copy everything else down. And the question is, what is left in the parentheses? If we take an h out of the first term, we're left with the 2x on that term. We bring down our plus, and if we take an h out of h squared, it's no longer h squared, it's just h to the first power, which is just h. Now you can convince yourself, if this is a little confusing, you can convince yourself that this is legal because you could imagine multiplying this h back through the parentheses. And if you did that, you would multiply h times 2x, which would give you 2xh, and you would multiply h times h, which would give you h squared. So you'd be left with the same thing you started with, so we know that that step is legal. Now the reason that we did that step is because, hey look, now my favorite thing to do is cancel. We can cancel the h in the numerator and the h in the denominator, and that just leaves us with limit as h goes to 0 of 2x plus h. Now we actually get to take a limit. It's an easy limit, but we get to take the limit. Taking a limit as h goes to 0, usually the first thing that you try to do is just plug in h equals 0. Can we plug in h equals 0? Yes, we can. We can plug it in right there. If we plug in h equals 0, we have 2x plus 0. And obviously 2x plus 0 is just 2x. So, to use our mathematical terminology, the derivative of the function that we started with, oh geez, what was it? X squared. We started with x squared. The derivative of that function is 2x. And if you want to use the fancy notation, that looks like f prime of x equals 2x. That means the derivative of f is 2x. Okay, now that we've done a couple of examples together, see if you can find a derivative on your own. So your video quiz is find the derivative of f of x equals 5x squared. See what you can do with that, bring it to class, and in class we will talk about what these derivatives actually mean graphically. In our previous class we talked about these derivatives representing a slope of a tangent line. So we're going to go back to that and talk about how that slope of a tangent line concept makes sense with these derivatives that we found. Alright, see you in class.